This is the final and most difficult of the examples on impulse momentum. It says a 0.4 kilogram super ball is dropped from a height of 25 meters and rebounds to a height of 20 meters. If a force of 28 newtons is responsible, so we have the force that's exerted as 28 newtons, what is the contact time? So we are trying to solve for the time. Now, since we're talking about force and time and all that, we know we're going to use Ft equals mvf minus mvi. However, I do not actually have the times. There's going to be two times that are going to be involved in here. The first one, or excuse me, two velocities that are involved here, and I got to figure out what they are. So the first one is the initial velocity in the collision. So the initial velocity in the collision is when the ball is moving downwards just as it strikes the surface. And then I'm going to have the final velocity, and that's going to be the velocity as it moves upward after rebounding. So we're going to have to be real careful here when we're starting to look at this. How am I going to figure out those velocities? And what I'm going to do is I'm going to use conservation of energy, or MGH equals 1/2 mv squared. Okay, in our case, mass is going to cancel out for this calculation that we're doing. So we're going to say that the fact that it falls 25 meters times 9.8 allows me to solve for the velocity that it's moving as it strikes the ground. So 25 times 9.8, move the 2 over to the other side, take the square root, and you get the velocity as it strikes the ground is 22.1 meters per second. Now, this is what I found by doing potential energy being changed to kinetic, but this has to be negative. The reason why it has to be negative is actually moving down as it strikes the surface. Now what I'm going to do is I'm going to solve for this final velocity using the exact same method but in reverse. I have a potential energy that's 20 times 9.8 equals 1/2 velocity squared. What that allows me to do is I can say 20 times 9.8, take the square root, and you get a velocity of 19 point, we'll call it 8 meters per second. Now that is a positive velocity because it's moving upward. Now that I have these two velocities, I can now plug in my original question and solve for the force. So it tells me that I have a 28 Newton force. I'm trying to solve for the impact time. I know that the mass of the super ball is 0.4. I know that my my final velocity is 19.8, and I know that my initial velocity was a negative 22.1. So if you look, 19.8, which is my final, minus a negative. Remember, when you subtract a negative, it becomes plus a positive. So what you have here is you have T is going to be equal to 0.4 times 19.8 plus 22.1, which is 41.9, and then all of that is over 28. Divided both sides by 28 there. So 0.4 times 41.9 divided by 28 gives 0.599 seconds, which is an awful long time with what actually happens with a super ball.